Hello friends. So in this video we will learn how to use PZEM004T for measuring various electrical parameters. So we can measure voltage, current, power, power factor, frequency and energy using this PZEM004T sensor. We are going to interface this sensor with Arduino. I'm going to use Arduino Uno for interfacing this, and I will measure the respective electrical quantities whatever I said just now. Let us go into the details. So this is the block diagram of this sensor PZEM004T, where I have a measurement system and I have a communication port here. So this is our communication port where I have a transmitter and receiver pins and the supply, and in the other side I have the signal or the quantity which has to be measured. So I need to give the voltage as well as the current signal to this energy sensor so that it can measure this voltage and current, and it do the calculation inside, and later it gives us the various electrical parameters. So I have a CT, current transformer, for measuring the current consumed by the load, where you want to measure the current or where you want to measure the power, and the supply voltage is directly given to this PZEM004T, so that the voltage and current will be multiplied and you will get a power. And also it measures the phase angle so that it can calculate the power factor, and it can calculate the frequency and so on. So this is the functionality of this sensor. So what are the ranges of electrical quantity you can measure using this sensor? We can measure the current rating. So we have two varieties, PZEM004 version 2, which can measure up to 10 amperes, and version 3 up to 100 amperes, and the voltage range can be from 80 to 260 volt. And power, it can measure, the 10 ampere module can measure up to 0 to 2.3 kilowatts, and 100 ampere sensor can measure up to 0 to 23 kilowatts. Power factor 0 to 1. So frequency 45 Hz to 65 Hz it can measure, and the energy 0 to 9999.99 kilowatt hour. So this is the range it can measure energy. So these are the some specifications about this particular energy sensor, and these are dimensions and all those things, working temperature and all. So these are the important parameters which you need to know. So based on the requirement, we can choose either 10 ampere module or 100 ampere module. So it does not have any much physical difference, but it has internally the component capacity is going to be different. Current transformer. So if you want to measure the current which is flowing to the load, so we need to use a CT. Okay, so we are going to use a CT. So based on the CT input to the sensor, so it is going to measure the current, and it will multiply with the required voltage so that it will get the power consumed by the particular load. So this is the overall connection diagram you can see here. So this CT and the supply voltage for the load what we given, the same potential is connected across this potential terminal. So these two are potential terminal where plus and phase and neutral is connected, and then here the phase and neutral of the current transformer output can be connected to this. So voltage input and current input is given to this energy sensor, and for the operating voltage of this sensor we need to give a 5 volt and ground here, and we have a communication ports, that is transmitter and receiver pins. So these two pins are used for serial communication between the external components or devices like your Arduino Uno or the laptop, whatever it is. Okay, so we can use this communication port. So this is how it will be connected to the Arduino. So I have connected these two pins, transmitter and receiver pin. So I'm going to use a software serial, so I can connect any pins and I can assign that one for a software serial. If you are using hardware serial, we can use this transmitter and receiver pin, that is 0 and 1. Okay, so this is our transmitter and receiver, and remaining connections are going to be same, the simple connection. Now let us see how the code looks like. So we need to add the header file for this energy sensor, which is available in the website. Include PZEM004T. I am going to use version 3, so this header file is named as version 3.h. And the second line is about PZEM004T version 30, PZEM. I'm going to use these two pins of Arduino 11 and 12. Okay, as I told you, I'm going to use a software serial. So for software serial, any Arduino digital pins can be used. So I'm going to use 11th and 12th pin. And I'm going to start the setup with a simple serial.begin. So I want to print all the values here. So I can put this one here. And then for the loop, since I installed already the header file here, so there is internal functions. We can just go ahead with the functions. We can call the functions and store the value in the variables. So float voltage is equals to, so PZEM dot voltage of. So voltage of is a function to measure the voltage and get the voltage value, and it will store in this variable. And it is going to compare if the voltage is available, then it is going to print the value here. Okay, so voltage equals to series voltage, and this is per unit. If not available, it will say error reading voltage. The same pattern is followed for all other parameters as well. So float current is a variable where I am going to store the current value, and this is a function PZEM dot current of. So function. So these functions are written inside this header file. So we just need to call, and it will have a inbuilt program to measure and conversions, whatever it is needed. Everything will be done inside. And if the current value is available, it will print in this line, and else it will go to the error reading current. And similarly for power, so if the power is available, it will print here. It is not available, it is going to print here. So for energy, same pattern, float energy dot is equals to PZEM dot energy of. So if you are using a different header file, maybe you will have a different the function name. Since this header file has the function name like this, it is declared like this here. So this energy can be renamed anything, but this function we have to use same like this because it is declared inside the header file like this. Okay, and for frequency, and similarly for power factor. So once I return the code, so I can execute the program and I can see the output. So let me execute the program. So this is the code I have written in the Arduino, just same program. I just copied it here, and I also included LCD here to show variable outputs in the LCD monitor. Since we are going to use it as a power meter, so I can keep the LCD so the system can work as a standalone device. Okay, so for the LCD, I've included the LCD header file, and I am going to use a 20 into 4 size LCD, and this is the one. Okay, and I can see in serial monitor as well as in the LCD. So wherever I need to print the values in the LCD, that also is given. So here you can see what are the values I want to print. Everything is given here. Set cursor, voltage, current, power, power factor, and whatever the values, frequency, whatever the values I want to print it, everything is given in this LCD. Hope you know how to use the LCD. for printing the values. If you are not known, so please go through the videos, the previous videos which I put for learn over the basics of Arduino. So there you can see the how to use LCD to print the values in the LCD. Right. So this is the code, and already I've connected it in the hardware. So now the serial data, you can see it is already measuring the values here. So I have connected a 240 volt supply, and I have connected a CFL lamp. So the CFL lamp is of 10 watts power rating, and the current is 0.08 amperes, and the energy consumed by that is 0.030 kilowatt hour, and the frequency 50 Hz. Power factor is 0.52 because it is a CFL lamp. So I will turn off now the CFL lamp, and I will switch on one incandescent lamp. Now let us see what happens to the power and other parameters. So now I switched on one incandescent lamp with 100 watts lamp. So you can see now the current, voltage, and energy, and also you can see the power factor. Incandescent lamp is a resistive load, so your power factor is almost equal to 1. So now let me turn on two incandescent lamp, each of 100 watts. So now you can see the power is changed to 200 watts, and the voltage remains same. The current increased to 0.84, and the frequency and power factor. So let me add one more lamp to this. So now 300 watts lamp is connected. So the total power is 311.8, and the power factor, frequency remains same. And now you can see the energy is increasing very fast because I am connecting now 300 watts a lamp now. So now I will add in one fluorescent CFL lamp. So what will happen to the power factor? So since it is only one CFL and three incandescent lamp, the power factor still it is same. Now I will switch off one two incandescent lamp. I switched off. So now the power factor 0.99, and when I switch off all the incandescent lamp, the power factor goes to 0.52. Okay, so this is about the data, and the hardware connection. It looks like this. I'll just play yes. So you can see this is the hardware connection. So I have a Arduino Uno here. So this is the Arduino Uno, and I have a LCD here, 4 into 20 into 4 size LCD, and this is my power meter, and this is my load box, and here from here I have the current sensor as well. So I'm going to switch on the load. Once I switch on the load, you can see the readings in the LCD. So it is one incandescent lamp, 100 watts. Now switch on two incandescent lamps. So it's a 200 watts. So two incandescent lamp, 200 watts, and 0.8 amperes current. And finally I will switch on one CFL lamp. Yeah, with the CFL lamp you can see 10 watts, and current and the power factor is this one. So it's very simple connection. You can make use of this sensor for measuring the various electrical parameters, and using these electrical parameters you can do lot of projects. So like a power factor correction, and automatic energy meter, prepaid energy meter, and lot of electrical projects we can do making use of this simple sensor. Hope you understood the concept and the connections. If you have any doubts, please let me know. Thank you for watching.